Hi, I'm Liz from the Gaia Project. This video is an introduction to the heating calculations that go along with the process of doing an energy audit. Before we get started, I suggest you visit our website at www.thegaiaproject.ca in order to find the project guide that goes along with these calculations. This video will make a lot more sense if you have that in hand as you watch it. We are now going to instead consider the whole building as an envelope. There are two sub-methods that we're going to use. The first one is the first one we're going to talk about. And there's one formula that's associated with it. Q is equal to A times T hot minus T cold, all divided by R. Now, in this case, the important things to know. A is the area of the surface at which you're looking at, and that's going to be measured in meters squared. T hot and T cold are both temperatures of the cold surface and the warm surface that you're looking at. In Canada during the winter, T hot is going to be the inside temperature, and T cold is going to be the outside temperature. These are both measured in degrees Kelvin. Since we're looking at the difference of the two, it doesn't really matter whether you measure them in Celsius or Kelvin, but if you're measuring them individually, you should be measuring them in Kelvin. And finally, R is our insulation value. It differs for the different materials that you're going to be looking at. And it's measured in meters squared times joules per second times Kelvin. This is called the SI unit, the Système International units for the R value. Generally, when you look this value up, it won't be given in these units, so you'll need to go through the process of converting it to these units so that you're able to use it in this equation that's shown above. For more information about finding an R value that is specific to your situation, please go take a look at the video on this subject that can be found on the Gaia Project's YouTube channel. It's called the Gaia Project Canada. Now that we've described the meaning of the different things in this formula, we need to figure out how to use it practically. In order to calculate the value of the heat being transferred from the hot body to the cold body, we need to figure out the total surface area of the entire school, which can be quite a job. We need to begin by collecting data about the area of all the surfaces around the school. So that includes walls, windows, and floors. The ground temperature in this case would be the T cold. And after collecting all that data, we can now estimate the heat loss for any surface under any different inside and outside air temperature conditions using this formula that we have described here. We can create a table in order to compile this data. However, you need to remember that this table will only be giving us the rate of heat loss at a given temperature. And this temperature is probably going to change during the rest of the day. Therefore, it's not very helpful in determining the energy loss over the course of a longer period. However, we can also use average daily temperatures, or weekly, or even monthly, which can be found on Environment Canada's website. Another option, instead of doing this for every single surface for a long period, which could be quite tedious, we could simply calculate an average R value using a weighted average that accounts for all of the different surfaces at the school. More details for this can also be found in the project guide, which is located on our website. The second formula that you're going to be introduced to includes an experiment that you're going to have to perform. Now, before you get started, there are a couple things that you need to think of. We're going to be looking at the process of a room cooling down over a time period of about 15 minutes. In order to make this experiment as valid as possible, we need to be able to assume that no heat is entering the room, heat's only exiting the room. In order to do this, you need to turn off all the heaters, block all heating vents, block the holes under the doors, and be sure that you yourself are outside of the room during this experiment, seeing as your body produces heat, and that could distort the results. You also want to make sure that you're looking at a short enough time period, about 15 minutes. Otherwise, the heat from the rooms beside the one you're examining will start to distort your results as well. Now, for the second method that we're using to calculate the heat transfer theoretically, we're going to be using the following formula. Q is equal to mc delta T, all divided by little t. Now in this case, m is the mass of air in the room. That's measured in kilograms. In order to figure this out, you first need to find the volume of the room in meters cubed by measuring its dimensions, and then using the density of air in that room, you can figure out how much mass there is of air. The C in this case is the specific heat of the air in the room. You can find this number by looking it up online or by looking in a variety of textbooks. Delta T is the change in temperature that the room undergoes over the period of about 15 minutes that we're looking at. You can either measure your temperatures in degrees Kelvin or in degrees Celsius, seeing as this case we're looking at a difference, therefore it doesn't matter. Finally, T is the amount of time that we're examining measured in seconds. The data that we've now collected only gives us information about what happens in a single room under a single set of conditions. However, from this data that we've collected, it's possible to get information that will help us apply this to the entire school building in order to be able to calculate the heat loss on a larger scale. Hopefully, this video helped answer most of the questions that you had about the process of completing these heating calculations. If you still have questions, feel free to watch the video again, or contact us with any of these questions. All of our contact information can be found on our website at www.thegaiaproject.ca. Best of luck in your projects!